Okay, let's get started with section 8.4. We will be doing dimensional analysis and conversions to and from the metric system. First of all, dimensional analysis is a procedure used to convert from one unit of measurement to a different measurement. So if you wanted to change from feet to inches or something like that, that's called dimensional analysis. This is the process of converting. A unit fraction. Unit means one, of course. So unit fraction is any fraction with a numerator and denominator that contain different units, and the value of the fraction is 1. So if you make a fraction with, these are some examples, 12 inches over 1 foot. We have different units, and that's what it says up here. The numerator and denominator contain different units, but we know these are equivalent. 1 foot is equivalent to 12 inches, so you can multiply by this, and it's the same as multiplying by a 1. And when you think about multiplying by a 1, that's what you want to do when you're working with things because it doesn't change what you have. If you have any number, let's say negative 10, and you multiply it by 1, you still have a negative 10. If you have a positive number, 37, and you multiply it by 1, you still have 37. So multiplying by 1 doesn't change anything. And so these unit fractions are what we need to work with to change units, to do dimensional analysis. Here's another unit fraction because 1 hour is equivalent to 60 minutes. Even though we have different units, these are equivalent, so it's like multiplying by a 1. 16 ounces is equivalent to 1 pound. Here are the customary units that you are expected to know or to put on your note card. So at this point, I would probably stop this video and pause it for a minute and put all of these onto a note card or copy them down. These are taken from the book. I think I have every table in this section. I hope I do. I think I do. So if you will just pause this video and copy these down, and this is so much better than having to do it in the lecture hall where we have to wait for everyone to copy, and different people copy at different speeds, and it's hard to read on the projector. So you should be able to get these down on your note card and have this ready. So these are things you'll be using throughout this particular section and this particular unit in the upcoming test, okay? And many of these you already know, some of them you don't know, okay? A ton is 2,000 pounds, so forth and so on, okay? So this was cut and pasted from the textbook exactly the way it is, okay? Let's move to the next page. We have another, we actually have our first conversion here. They're asking us to convert 2 1/4 hours to minutes. So what I'm going to do is begin with teaching you the way to do this the way that they do in science classes. This is one of the things they ask us to cover in Math 105 for the science department, okay, science majors, well, not majors, but non-science majors. First, we start with 2 1/4 hours. A fourth, if I use my calculator, can be rewritten as 0.25. So this is the same as 2.25. Take 1 divided by 4 on your calculator. This is what we're starting with. And decimals are much better to work with a fraction. So I take my given amount, 2.25 hours, and I put it over 1. Now they want me to change that to minutes. Change it into minutes. So I need to multiply by one of these unit fractions, and the unit fraction needs to get rid of the hours. So I put the hours in the denominator because when I divide by the same thing, hours over hours will cancel, okay? And I want to change to minutes, so I want the answer to have minutes. Oops, I have rather bumpy M there. Minutes, okay? And then we need the relationship. 1 hour is equivalent to 60 minutes, and that's on the page before, I believe. I don't know. Yes, it is. You'll see it in the second column over here. And so that's a unit fraction. We can multiply by that. So at this point, what we do is we cancel the hours divided by the hours. Anything over the same thing as 1, just think of that. X over X is 1. 5 over 5 is 1. Anything over the same thing is a 1. So we cancel the hours. And then we multiply the numerators going across, and we multiply the denominators going across, and we keep whatever units are there. So we take 2.25, sorry for bumping around here, 2.25 multiplied by 60. I seem to be on the wrong page here. Let's see if I can get on the right page. Grab your calculator and multiply. Okay, clear. 2.25 multiplied by 60 is 135. So this is going to be equivalent to 135. Notice that the units that are left are minutes, and they ask us to change hours to minutes, so we have succeeded here with this. Good. Okay, and now we're going to convert 20 years into hours. How many hours, when you're 20 years old, how many hours have you lived, right? 20 years is what we're given, so we always place that over 1. And we multiply by a unit fraction that will change out of years, so I put years down here, and into hours, because they want us to go 2 hours. And what's the relationship here? Well, look on your table and see if it tells you how many hours are in a year. It says how many hours are in a day, and it says how many days are in a year. We can't do this in one step. So on this particular problem, we're going to have to work it into 2 steps. I wish I could find my white out. Let me look one more place real quickly. Yes, I see it. So, since we don't have a direct equivalence on this chart over here, and I looked again, and I see that 1 day is 24 hours and 1 year is 365 days, I can only go from hours to days. Okay, so I'm going to have to do this in 2 steps. So instead of going from years to hours, I have to get out of years. From years, I can get years to days at the very bottom. Years to days. 1 year is 365 days. Okay, and sometimes you'll notice that it takes 2 steps to do this. Most of them work in 1 step with 1 equivalent unit fraction. And now we don't really want days. At this point, we've changed out of years, and we'll be in days at this point, but we want not days, so we put it in the denominator to cancel. We want to go from days to hours, because our goal was to get it to hours. And we know that 24 hours makes 1 day. That's on the chart. So it was necessary to use 2 unit fractions here. The days cancel, and we multiply across the numerator. Okay. And that's going to give us 20 multiplied by 365 multiplied by 24 is 175,200. 175,200. Look at your units. Everything's canceled out but the hours. So we started in years and we ended up in hours. We have succeeded. This is your answer. Okay. Here is the next table of unit fractions or equivalences that you need. I would put these on my note card if I did not already have them memorized. And many people don't have these memorized. That's kind of weird if you do. Whoa. My projector thing is falling down here. See if I can tape it up a little bit better. There we go. All right, I'll give you a second to copy those. You may want to stop the camera and do that at this time. This next example asks us, and it's going to use facts from this chart, to take 82 inches as our given amount and change that to centimeters. So we want to get rid of the inches. So in the denominator, I place in inches that will cancel out, and I want to convert into centimeters. Hopefully we can do this in 1 step. We always write it this way. We may have to erase and do it over. Inches and centimeters. The very first one says that 1 inch, notice I put the 1 in front of the inch because that's where it was, and 2.5 centimeters, that goes over here with the centimeters, 2.54 centimeters. Okay, now we notice that the inches cancel. We multiply across. We have 82 multiplied by 2.54 is 208 point, let's see if I did that right. Oh, it looks like I got some extra numbers typed in there. Let's try this again. 82 multiplied by 2.54, there we go, is 208.28. Good. 208.28 centimeters. Good. Now what you may want to do as we work through these is try the examples on your own, pause the video, and then turn it back on to check and make sure you're able to get it. That's one of the nice advantages of these recorded videos. Okay, the end of that page. We have a new table, and this has to do with areas. So you will want to put these equivalences on your note card. Any of these things could come up on the test. I will not give you these on the test. You have to have them on your note card or memorized, whichever you prefer. And most people prefer the note card. Okay, number 4 asks us to convert 20 square yards, so that's my given. And we could write this like this, yards squared, or square yards like that, either way. And we're going to convert out of the square yards and go to square meters. Okay. All right, so we look above to see if we have a relationship between square yards and square meters, and we do. It's the third one. 1 square yard is 0.8 square meters. Excellent. So we cancel the yards squared, and we multiply across the numerators and across the denominator. We just get a 1, right? So I take 20 times 0.8, which is going to give me a 16 meters squared. Very well. These are not hard at all if you have those equivalences and you just remain calm. 6.2 acres. And that's our given, and we're supposed to change it to, and I have no idea how in the heck to say hectares. I think it's hectares. Oh well. We're going out of acres into HA is the abbreviation for that. I can see that at the bottom right up here. 1 acre is 0.4 of these HA units. Okay, 1 acre is 0.4 of these. Notice the acres divided by the acres makes a 1. They cancel. And I multiply 6.2 multiplied by 0.4 gives me a 2.48. And I will tell you how to round these if they're not multiple choice on the test, or on my math lab, of course, you can redo it with no penalty if you don't have the right rounding. Usually they just leave whatever's there. Very well. These are moving right along here. Take that page off. Somehow these got stapled together. The next conversion box includes conversions for formulas with volume, right? We're going from teaspoons to milliliters and fluid ounces to milliliters, pints to liters, and so forth. So get those onto your note card, please. And then we'll begin converting using these units. We have 2.3 liters. That's our given. And we're supposed to change from liters to pints. So we will look and see if there's a direct conversion for this. 1 pint is 0.47 liters. I am happy that we finally have something in our denominator here. Okay, so the liter units cancel, and I multiply across the numerator and I get 2.3, and across the denominator I get a 0.47, and the units will be pints. So we go ahead and take our calculator and divide this out, okay? 2.3 divided by 0.47 is, oh well, they need to tell us how to round this. Let's round it to the nearest hundredth. That's glary on your calculator there. See, it's 4.89. Let's do it 2 places after the decimal to the hundredth. So we'll say 4.89. 4.89. You must remember your units. You can write the word out or put the units, because there will be a deduction for leaving your units off on unit conversions on the next test. On my math lab, they always write the units for you, so you just have to type in the number, which means you're really going to have to remember or make a note on your note card to put the units on these. I will have a note on the test also to remind you. We're taking 50 teaspoons, and we're converting that to ounces. Okay, so I need to get out of teaspoons. That's the first step, is getting out of what you start with, and get to ounces. Let's look above. I happen to know what's going to happen here. We have teaspoons to milliliters. We want ounces. We have tablespoons. That's not going to help us. Ounces to milliliters. So you can see here we're going to have to go from teaspoons to milliliters, and then from milliliters to ounces. We're going to have to make it in 2 steps, because I can see how to go from teaspoons to milliliters, and I also can see how to go from milliliters to ounces. So I'm going to do it that way. Teaspoons to milliliters will be my first step, and the relationship is that 1 teaspoon makes 5 milliliters. Okay, now I got out of teaspoons and I made it into milliliters. The next step is to change out of milliliters and get to ounces. So I find that equivalence. 30 milliliters is equivalent to 1 fluid ounce. Very well. And so the milliliters cancel, and I multiply across the top, and I have 250 divided by 30, and the only unit left is ounces. So let's go ahead and reduce that. Grab my calculator. 250 divided by 30 is 8.3 repeating. So let's do 2 decimal places again. 8.33 to the nearest hundredth ounces. Okay. Very well. Looking good. This should be easy. The tests last time were pretty good. I want to warn those of you who are in nursing, if you are a nursing major in the health sciences, some of their conversions are a little bit different. So in nursing you should use theirs, and in Math 105 you should use the textbooks, my math labs, okay? I am aware that there are slight differences in the rounding. Okay. Some more conversions for volume. These are metric and US conversions, quarts to liters and gallons to liters and cubic foot to cubic meters and yards to so forth. Get those on your note card. Let's go ahead and convert 5 gallons. Remember that you can pause this if you are not done copying those down. And we want to get out of gallons and change to liters. And we have a direct conversion here. 1 gallon is 3.8 liters. 1 gallon is 3.8 liters. Now we convert by canceling those. We multiply across the numerator, and that gives us 19 liters, I believe. Let me double check that. Clear. 5 multiplied by 3.8 is 19. It is 19 liters. Okay. And some more conversions that you want to put on your note card. This is going to be the easiest anyone has ever had a time of making their own note cards, okay? Get those on your note card. Good. Pause it if you need to. And let's work some with those conversions. Let me keep those handy in case I want to look at them. We're beginning with 9 pounds. And we're going to change that to kilograms. We hope in one step that we can go directly from pounds to kilograms. All right, and I look on my lovely little page here. 1 pound is 0.45 kilograms. 1 pound is 0.45 kilograms. The units will be canceling. And now I take clear 9 multiplied by 0.45 is 4.05. And the units are now kilograms. Just remember those units. Very well. Another example, taking 4 I thought it was tablespoons, but then I see this tons. They're using, they actually write out tablespoons if you look back on with a capital TBS or something like that. This is 1 ton of one type to, this is a TON to a TONNE, and the symbol for this is a little t, okay? So we're going to take 4 capital T to little t. Okay, let's look on the page before we make some sense out of this. This one almost always shows up on the test. Since you're planning for your test, you make sure you get this one on there. One of these capital T tons, TONs, is equal to 0.9 of the TON and E tons, okay? And that usually shows up. I'm warning you. So we want to get out of the TONs to the TON and E's. And the relationship, one of these is the same as 0.9 of those. Units cancel. So I take 4 multiplied by 0.9, 3.6. And it's the little t, okay? T-O-N-N. Okay, or the little t, either one. Very well. We have some more examples. Practice is the way you learn math, is by practice, just like any sport, same thing with mathematics. Weasley's new car, I know y'all are probably sick of Weasley, traveled 105 miles on 5 gallons of gasoline. I think that should be a period. Oh well, slight typo. How many kilometers can his car travel with the same amount of gasoline? Okay, this gasoline is just here to trick us. We don't really care anything about the gasoline. We've got 5 gallons, and we're going to use the same amount. The question is, if you traveled 105 miles, how many kilometers is that? So they're asking me to convert 105 miles to kilometers. Okay, and the 5 gallons of gas, it doesn't really matter because it's the same amount of gas. We don't need to calculate the gas. You probably could include that and do it a little more complicated manner, but it's not necessary. We begin with the distance that we're converting, and we want to know with the same amount of gas, if you measured it in kilometers, how much would it be? So we're changing out of miles into kilometers, and the relationship from the table is that 1 mile is 1.6 kilometers. And that was one of my early tables. Let's see if I can see it and put it up here in front of you. Yeah, it was way back here. 1 mile is 1.6 kilometers, okay? So I may not be showing you all of these. I'll just look and tell them to you. Okay, so I multiply across the numerator, and I take 105 and multiply that by 1.6, and that gives me 168 kilometers. Very well. Now we want Chicago to Atlanta. The distance from Chicago, Illinois to Atlanta, Georgia is about 717 miles. What is the distance in kilometers? This is the same problem we just did, essentially with different numbers. 717 miles, and we're going out of miles into kilometers. Okay, I hope that you can do this without even watching what I'm doing. And we multiply across. 717 multiplied by 1.6 is 1147.2 kilometers. Very well. A swimming pool holds 12,500 gallons of water. What is the volume in kilometers? So we're supposed to go from gallons to kiloliters. I say kilometers, kiloliters. That makes a lot more sense actually. So we're starting with 12,500 gallons over 1, and we want to go from gallons to kiloliters. Okay, let's get out the lovely conversion thing. Said I wasn't going to do that, but I am. And it was one of the more recent ones. Yes, here it is. I see gallons to liters. There's not anything about kiloliters there, is there? Okay. Let's see about this other conversion. Let's see if I've got it here. Inches. I know what it is. but I was hoping to find the page that would help us. Do you know what kilo means? I really thought we had that chart already. Looking back through the notes here. Kilo means 1,000, okay? So 1 kilo anything, in this case kiloliter, is going to equal to 1,000 regular liters. Okay, so it takes 1,000 of a regular liter, 1,000 meters to make a kilometer, 1,000 of anything to make a kilo of the same thing. Okay, and I'm still looking. I thought we had a metric conversion that gave kilo, but I don't see it, and that's making me upset. That makes me think there might be another chart in the book that one needs for kilo and centa and all these metric prefixes. I thought we had a metric prefix chart. And I really don't see it. I'm going to give you a couple more since I'm not seeing this. You may want to look at your book. Centimeter, centa means 100. So 100 centimeters equals to 1 meter. There's another conversion. So it takes 100 centa anythings to make whatever that is. So now that we know this, we're going to be able to convert from gallons to liters and then from liters to kiloliters. Okay. All right, back to this problem here. We can't go directly to kiloliters, so erase that. I'm erasing with liquid whiteout, right? We're going from gallons to liters because on the paper there it said that 1 gallon is the same as 3.8 liters. Okay, that's the first step. Now we've changed to liters. So we're going from gallons to liters and then from liters to kiloliters. And we know now, some people put these vertical lines like in science classes, so I've resorted to that. Liters to kiloliters. And 1 kiloliter is the same as 1,000 liters. All right, this is set up well. Units cancel, and the units will be kiloliters on the answer. Multiply across the numerator and divide by the denominator, right? And when you do that, you should get 47.5 units kiloliters. Okay. I'm going to go ahead and double check the multiplication. 12,500 multiplied by 3.8 equals, and divided by 1,000. Yes, 47.5 is the answer. Very well. And there won't be but 1 or 2 with 2 steps on it, but you will have a couple on your next test. A basement is to be 50 feet long, 30 feet wide, and 8 feet high. Okay, so you've got, got yourself a basement. I'm not great at drawing, but I like to do it. Okay, so you've got a basement, and they're telling you that's 50 feet long, 30 feet wide, my drawing is clearly not to scale, and 8 feet tall. How much dirt will have to be removed when the basement is built? Obviously, this is not realistic. They remove more dirt than the actual basement, but we'll pretend they're removing exactly as much as the basement, okay? So, and they want the answer in cubic meters. If we calculate it now, the volume of the basement will be the length times the width times the height, which in this problem will be 50 feet multiplied by 30 feet multiplied by 8 feet, which will give me 12,000 feet cubed. Feet times feet times feet is cubic feet. Now let's double check the multiplication there. We're taking 8 multiplied by 30 multiplied by 50, and that gives us 12,000 sure enough. Okay. Now that's in cubic feet, and that was the easiest thing to find. Now they want us to change it to cubic meters. It's easier to do the volume and then change the whole volume. So let's take the 12,000 cubic feet volume of this basement, place it over 1 as the given, Again, you don't need those lines, but I like them. And we're going from cubic feet to cubic meters. And I do think that that equivalence was given to us. Yes. 1 cubic foot is 0.03 cubic meters. 1 cubic foot is 0.03 cubic meters. Those cancel. And I multiply across. So I'm going to take this 12,000 that's still on my calculator and multiply by 0.03. And that gives me 360 meter cubed. Cubic meters, meter cubed. Very well. These are really kind of fun if you don't mind looking up the conversion units, the unit fractions. Okay, dosage for a child. I almost always put one of these on the test, okay? It's a two-step problem, which makes it a little bit harder. The recommended dosage of the drug codeine for pediatric patients is 1 milligram per kilogram of a child's weight. Okay, so that's how much they dose it. It's based on the weight of the child. What dose of codeine should be given to Neville, who weighed 56 pounds? That was a long time ago, right? So we take 56 pounds, and the first thing we know is that the medicine, they tell us 1 milligram per kilogram of the kid's weight, and we don't know his weight in kilograms, we know his weight in pounds. So the first step is going to be to convert 56 pounds to kilograms. That's the first thing we need to do. Okay, his given weight over 1, and I'm going out of pounds into kilograms. And if you look that up, you'll find that 1 pound is 0.45 kilograms. That's a unit fraction. Then the pounds cancel, and we multiply across the numerator. You're going to get 25.2, and the units are kilograms. Okay, good. Now we need the dosage. How much dosage? How much med? Codeine, to be specific, okay? The kid's in pain. So we're going to take 25.2 kilograms and put that over 1. And we're going to multiply by the dosage. It says that we need to get out of kilograms, right? And it says he gets 1 milligram per. Remember, per means divided by. So 1 milligram per every 1 kilogram of the weight. It didn't say 1, but we know it's 1 because it didn't tell us another number. Okay, the kilograms cancel, and we multiply across, and we will get 25.2 milligrams of medicine. Okay, now in this particular problem, I don't like it. I probably wouldn't give you one like this. But with the 1 milligram per 1 kilogram, when you do the first conversion, you actually get the right answer. You just have to change your units. The next example is actually going to be more like what we would get on a test, okay? So let's do it. It's another dosage problem. Again, there will be one dosage problem you can anticipate on the next test. The recommended dosage of the drug ampicillin for pediatric patients is 200 milligrams per kilogram of weight. So there's my conversion, right? You can even write that down over here. We have 200 milligrams per 1 kilogram of weight. That's the dosage. Of what drug? We have no idea. Ampicillin, there we go. If Luna weighs 76 pounds, okay, we'll place that over 1. How much ampicillin should you receive? Okay, this is dosed in kilograms. So like before, the first step is to convert the pounds to kilograms. So I'm changing the pounds to kilograms. Having trouble writing all of a sudden. And we know that 1 pound is 0.45 kilograms. So we multiply, and clear, we should take 76 multiplied by 0.45 is 34.2. Her weight is 34.2 in kilograms. Now we take her weight, place it over 1, and we multiply by this dosage. And the dosage isn't really a unit fraction, it's a dosage. And we know that we want kilograms to cancel, and it is in the denominator. 1 kilogram of weight gets 200 milligrams of ampicillin. So we multiply across that way, and we're going to get 68, 40, 68, 40. Let's double check that. So we have 34.2, and we're going to multiply that by 200. 6840 with a decimal at the end. 6840 milligrams of ampicillin. Okay, excellent. Okay, make sure that you understand those. There will be more of those practice problems with dosage on your My Math Lab homework, which I hope you're keeping up with. Car's engine. A specific car engine has a capacity of 5.7 liters of oil. How many quarts of oil does the engine have? So we're going to convert from liters to quarts. No big deal. We're given 5.7 liters. Place that over 1. And we're supposed to change out of liters and go to quarts. There is a direct equivalence on the charts. 1 quart is 0.95 liters. So that's going to give us a 5.7 over a 0.95, which is going to be 6 quarts. Perfect. All right, let me double check your multiplication there. We're going to take 5.7 and divide by 0.95, and sure enough, it gives us 6. Okay, all is well. One more page. Disney Magic. Aha. The Disney Magic cruise ship is 964 feet long and has a weight of 85,000 tons and can travel 25 miles per hour. Lots of interesting trivia about the Disney Magic cruise ship. Determine the length of the ship in meters. Length in meters. So the length is in feet, and I'm going to convert it to meters. So that's all I need right now is the length. So I have to start with 964 feet over 1, and I want to change out of feet and into meters. And if you look back, we don't have a conversion for that. So let me flip back to that page and show you what we're going to do. We have that 1 yard is 0.9 meters. And on another page, we have that 1 yard is equal to 3 feet. Right? So in other words, if 1 yard is the same as 3 feet, then 3 feet is equal to 0.9 meters. Okay, so you can do it in one step. I'll show you that way first. Feet to meters, we know that 3 feet is the same as 0.9 meters. Feet cancel. And we're going to get a lovely, let's just do this. Okay, 964 multiplied by 0.9 and divided by 3. 289.2 meters. Okay, some of you may prefer to have set this up as 964 feet over 1, and then you could say I'm going to go from feet to yards. 1 yard is 3 feet, and then go from yards to meters. 1 yard is 0.9 meters. Okay, and that would have worked just the same because it's really the same numbers. I've just made one less step this way. So whatever's best for you, please do that. Now we're going to convert to TONNES, and we were given TONS. Okay, remember this is this is one that's probably going to show up. We're going to start with 85,000 TONS over 1. And we're wanting to get out of TONS and go to TONNES. And we won't even worry about the big T, little t. Let's look that up on my handy dandy charts, which I think I've totally scrambled at this point. Oh well, they're all here. Yes, the last one I found. One TON is 0.9 TONNES. 1 TON is 0.9 TONNES. Good. So we're going to multiply that, and you will get 76,500 TONNES. That's good. And then they want us to change the speed to kilometers per hour, and it was miles per hour. So we don't really have to worry about the per hour. We can simply go from miles to kilometers, right? So we're going to take 28 miles. It travels in an hour. How did I write my units here? Let's see. Okay, let's just leave that 28 miles per hour. And then what we want to do is get out of the miles and change it to kilometers. We don't worry about the hours. And it turns out that 1 mile is 1.6 kilometers. That is on one of your tables with a 1 direct unit conversion, unit fraction. And so we multiply, where the miles cancel, we multiply across, divide by 1, should get 44.8. Now let's look at the units. It's kilometers per hour, okay? And that's kph, which is what they told us, kilometers per hour. Kilometers per divided by hour. Okay, finally, this is an interesting one because it involves using something that really you're not probably familiar with, or not many of you will be very familiar with this. On February 25th of 2010, the conversion rate for the US dollar was as follows. So the value of the dollar changes, the value of other currencies change, and this is the conversion rate as of that date. The US dollar, that means 1 US dollar, right? It could buy 0.74 euros, 1.06 Canadian dollars, or 12.85 Mexican pesos. Using this information, determine a unit fraction. Okay, and we're supposed to get a unit fraction to go from euros to Mexican pesos. Essentially what they're telling us here is that $1 is going to be equal to 0.74 euros. I won't write the symbols, we'll write the words. And that's equivalent to 1.06 Canadian dollars. Write the word. Which is also equivalent to 12.85 Mexican pesos. So any of these equals $1, so they all equal each other. It's one grand equivalence. And the fact that this equals this and that equals the dollar, by the transitive property, they equal to each other. Euros to Mexican pesos. We are wanting to convert, using this information to determine, we want to be given euros. And we're going to convert those to Mexican pesos. So if we're taking a given and putting it over a 1, a given euros, then when we make our fraction, we want euros to be in the denominator, okay? Because they're going to give us euros and we're changing it to Mexican pesos. So we want the answer to have Mexican pesos in the numerator. All right, so we know that 12.85 Mexican pesos would be equivalent to 0.74 euros. Now, they're not going to give you these fractions. Always one of them is simplified. So let's go ahead and take our calculator and take 12.85, clear, 12.85, and divide it by 0.74. And so we get 17, we'll do to the 100th again, 17.36 Mexican pesos per 1 euro, okay? And this is rounded, and they're going to use some sort of rounding. They did, in the ones we had up here, they used 2 decimal places after the decimal, right? 2 places after the decimal. So that's what we'll leave here, Okay, so this is our conversion. For €1, you get this many Mexican pesos. Now here they say if you're given Canadian dollars, they want you to convert to euros. So we're going to be given Canadian dollars over 1. So when we make our unit fraction, the denominator needs to have Canadian dollars and the numerator has to have euros. That way we'll be able to cancel and have the answer in euros. Okay, now we look up here. How many euros? 0.74 euros, and we have 1.06 Canadian dollars. So we go ahead and take our calculator and divide this out. I'm going to take 0.74 and divide it by 1.06 to make a single decimal number. 0.698. If we keep 2 places after the decimal, the 8 will round that 69 up to a 70. 0.70 euros is going to be equivalent to 1 Canadian dollar. Okay, that would be the unit conversion, unit fraction as they're calling it. I probably should not be capitalizing my euro, so if that bothers you, please change it to a lowercase e. Now we're going to go from Canadian dollar, that's what we're going to be given, and we're going to change to Mexican pesos. So to get rid of the Canadian dollars, it needs to be placed in the denominator. And in the numerator, we need to put Mexican pesos. Okay, and we look up here. Mexican pesos 12.85 and Canadian dollar 1.06. It's going to be just a little less than that. So we take our calculator and we take 12.85 and divide it by 1.06. And that gives us 12.122, which stays at 12.12 Mexican pesos over 1 Canadian dollar. And you need to have it simplified like we've done all of these, okay? All right. I hope you're doing well. I will see you very soon. Make sure that you complete your My Math Lab homework now on section 8.5, okay? Sorry, 8.4. Said the wrong thing. I will see you back very soon. Keep up the good work.